Day 2 rational functions and their graphs. Our learning goal is that you will be able to identify vertical and horizontal asymptotes. So let me give you the form for a rational function. Usually this is the form. Sometimes you may have it where you don't have a k value. And you'll have a rational expression on the top and the bottom without a h and k. So it may come in those two forms. So what happens is you have what are called vertical asymptotes, where this is the value that makes the denominator 0. And I may abbreviate it as VA, so if you see that. So it values of x that make the denominator 0. So we've done those before. And on the graph, your graph can't touch the vertical asymptote. So to get really close to it, but it can't touch it. And then horizontal asymptotes, which we're going to cover later. Sometimes your graph may touch the horizontal asymptote. So you may have two branches on the end and in the middle. See, sometimes it may touch the horizontal, but never touches the vertical asymptote. So we're going to use example 1 to help us find vertical asymptotes. A rational function may have several vertical asymptotes, and the graph can never intersect a vertical asymptote. Remember, it may cross the horizontal, but never intersect the vertical. All right, so we're going to find, remember we're looking for values of x that make the denominator 0. So look at example A. And you always want to make sure it's factored out first, because that can help you identify it. So if you look, it's already factored. You're looking at the denominator. The only value of x that would make the denominator 0 is 3. So our vertical asymptote would be, and it's a line. So you write it x equals 3. Okay? Part B, if you notice, there's no common factor, so we can't simplify anything. We have 2 vertical asymptotes now. So we have x equals 0 and x equals 3. Part C, we have a common factor, so we have to simplify it first, which leaves us with 1 over x minus 3. So now our vertical asymptote is x equals 3. So remember, you have to simplify first. And we're going to learn about this later. And then part D. If you notice, there are no real numbers that make the denominator 0. Make denominator 0. So no matter what value you plug in for x, there's no way you can make it 0. And if you don't believe me, you can always set it equal to 0. And what's going to happen is you're going to square root a negative. So you won't get a real number. So in this case, for the vertical asymptotes, there are none. Okay, finding horizontal asymptotes is a little different. Many, but not all, rational functions have horizontal asymptotes, and they can only have one horizontal. So different from the vertical. You can only have one horizontal asymptote. Now, if it's in this form, your horizontal asymptote would be, I'm going to call it HA, y equals k, because it's a horizontal line. But if there is no k, if there is no k, then we have to follow, we have to check for three things. So it'll be in a different form. So you'll have a rational expression on the top and one on the bottom. So what you're checking for are the degrees. Remember, the degree is the highest exponent. All right, so you're looking for the degree. You're comparing the degree in the numerator, I'm going to call it n, and the degree in the denominator, ND, numerator, denominator. So, case number one, the degree in the numerator is smaller than the degree in the denominator. Then your horizontal asymptote will be y equals 0. Okay, so remember we're checking the degrees. Case 2, if the degree in the numerator is equal to the degree in the denominator, then your horizontal asymptote will be y equals the leading coefficient, L, leading coefficient of the numerator over the leading coefficient of the denominator. And you have to simplify it if you can. And I'll write it here. Leading coefficient. Okay? And then case 3, if the degree in the numerator is larger than the degree in the denominator, your horizontal asymptote or your graph will have no horizontal asymptote. And you're going to have what we call a slant asymptote. But we'll talk about that when we start graphing. Okay, example 2. Now we're going to find the horizontal asymptotes, if any, because it may not have one, of the graph of each rational function. Okay, A. So remember we look at the degrees. The degree is the highest exponent. The degree in the top is a 1, and the degree in the bottom is a 2. So since the degree in the numerator is smaller than the degree in the denominator, your horizontal asymptote is y equals 0. So I hope you're getting it. Example B. My degree in the top is 2. My degree in the bottom is 2. So the degrees are equal. So in this case, you look at the leading coefficients. So the leading coefficient in the top is 15, and the one in the bottom is 3. So you write it like this: y equals 15 over 3, and then you simplify it, y equals 5. C, the one in the top is a 3, the degree in the bottom is a 2. So the degree in the numerator is larger. So for the horizontal, we would write none. No horizontal. And D, the degree in the top is a 1. The degree in the denominator is a 1. So they're equal again. So remember, you look at the leading coefficients. The leading coefficient in the top is a -3, and the one in the bottom is a 5. So you write it like this: y equals -3 over 5. This one can't simplify, so this is your horizontal. So your horizontal asymptote can be a fraction, just to be a little more difficult to graph than an actual integer.